Hi everyone, it's Mr. Barbier back with another video. Today's video is part 2 of Introduction to Functions. So in our last video, we learned how to determine whether a relation in the form of ordered pairs is a function or not. Okay, so for example, this is the relation we talked about in the last video. Okay, and notice this same relation here, given in the form of a set of ordered pairs, is also represented here as a table, here as a diagram, and here as a graph. So all four of these are the same thing, okay? This table, this diagram, and this graph are all visual displays of the same relation here, which is given in the form of ordered pairs. As it says here, right, all three displays above represent the same relation, which is this relation right here, okay? We know how to determine whether a relation given in the form of ordered pairs is a function. We learned this in the last video. And just to repeat very quickly, right, we said that as long as the first coordinate of each ordered pair is a different value, then this relation is a function. So let's look at all of the first coordinates, which is also known as the x values. We have -2, -1, 0, 1, and 2. Notice none of those first coordinates are exactly the same. In other words, none of them repeat. Therefore, this relation is a function. And since these three visual displays represent this same relation, that means that this is also a function, this table. This diagram is also a function, and this graph is also a function, because these three visual displays is the same thing as this. It's the same thing as this relation down here. These three visual displays represent this relation. So what we're going to do in this video is we're going to look at more visual displays. We're going to look at other tables, other diagrams, and other graphs to see what makes them functions or not. That's the focus of today's video. All right, so let's do it. Let's get right into it. Here we have relation in the form of a table. Is it a function? Okay, let's read. When a relation is given in the form of a table, how do we know if it is a function? Follow these easy steps. Step 1, focus only on the coordinates labeled domain or x. Remember that the set of first coordinates are also known as the domain. Okay, we learned that in the last video. Number 2, look to see if there are any repeating values in the domain. Okay, again, we're looking for repeating values. Okay, that doesn't change. Step 3, if there are any repeating x values, it is not a function. As always, that's just how we did it when we were looking at relations in the form of ordered pairs, correct? There was no difference. But if none of the x values repeat, it is a function. It's that simple. Okay, let's look at an example. Here we go. So, example, determine whether the table below is a function. So here's the table, and look at the difference, ladies and gentlemen. It's a very simple difference. Instead of ordered pairs, we now have a table in which the domain, also known as my x values or my first coordinates, are on the left side of the table, and my range, also known as my y values, are on the right side of the table. It's that simple, okay? It says here, notice that in the table, the x values do not repeat. let's make sure. Let's take a look here, right? 6, 5, 1, -1. Now somebody might say, wait a minute, Mr. Barbie, hold, wait a minute. I see 2 1s. That repeats. Remember, we covered this in the last video. If the signs aren't the same, it's not the same number. Okay, this is a positive 1 and it's a -1. Okay, so none of these first coordinates repeat themselves. Okay, therefore this table represents a function. Okay, let's continue reading here. Even though there are 2 9s in the range, look here, see, 9, 9. That doesn't matter. Remember, only the x values matter when determining whether a relation is a function, not the y values. Also, don't get fooled by the 2 1s in the domain. The signs are not the same. Therefore, they are not the same number. Answer, it is a function. It's that simple, ladies and gentlemen. It is that simple. So all you have to do is look at the table, focus on the domain, only the domain, and say to yourself, do I see any repeating values in the domain? Okay? Another word for values are elements. Do you see any repeating elements in the domain? If the answer is no, this table is a function. Okay? And one thing I want to say to you is that sometimes tables are not represented vertically. Sometimes they're drawn horizontally, meaning left to right. If that's the case, just follow the label. Look for domain and look for range, and it's the same thing. Okay, it's no different than this. So not all tables are drawn up and down, vertical. Some are drawn horizontal. Just want to make sure that you are aware of that. Now look here, classwork practice. Okay, so you're going to do these 4 problems by yourself. 1, 2, 3, and 4. All right. You're going to determine if each table represents a function. And then on the bottom, we're going to explain your reasoning. So if this table is a function, you're going to circle yes. If it's not a function, you're going to circle no, and then explain why on these lines. The same thing for number 2, for number 3, and for number 4. Okay? You got this. It's easy. I know you see it right now. Just by looking at the problems, you can see which ones are functions and which ones are not. So you're going to do these 4 as classwork practice. All right, let's move on. Number 3 of this particular lesson is relation in the form of a diagram. Is it a function? Let's read. When a relation is represented in the form of a diagram, how do we know if it is a function? Follow these easy steps. Step 1, focus only on the coordinates in the oval labeled domain. Okay? Again, focus only on the coordinates in the oval labeled domain. Once again, we're focusing only on the x values, not on the y. If there are 2 or more arrows connected to the same number in the domain, going to 2 different numbers in the range, it is not a function. Okay, so that's what we're looking for. We're looking for 2 or more arrows connected to the same number in the domain. Okay, we're going to look at some examples in a minute. Okay, so just be ready for that. Step 3, if each number in the domain has only 1 arrow connected to it, then it is a function. It is that simple, okay? It's that simple. Example, determine whether the diagram is a function. All right, so let's not even look at, guess what? I'm not even going to look at this right now. Let's cover that. Let's just focus on the diagram. Folks, based on what I just read, tell me whether you think this diagram represents a function, yes or no. Okay, I'm listening. Okay, I'm hearing a student say, Mr. Barbier, I think the answer is no, it's not a function. Okay, tell me why. Because you just said, let's look back, you just said that focus only on the coordinates in the oval labeled domain. Okay? If there are 2 or more arrows connected to the same number in the domain, then it is not a function. Do I see 2 or more arrows connected to the same number in the domain? Look at this 2. There is 2 arrows leaving the 2, going to 2 different numbers in the range. Guess what? This diagram does not represent a function. And let me explain this in another way. If I were to ask you, give me the coordinates of this diagram, the coordinates that represent this diagram, you would tell me, well, one ordered pair, one set of coordinates would be -2, 6, and then another set of ordered pairs would be -2, 10. So if that's the case, I'm using -2 twice in the domain. That means I have 2 ordered pairs with the same x value. This is not a function. It's that simple, okay? Let's read this explanation really quick. Notice that there are 2 arrows going from -2 in the domain to different numbers in the range. There are also 2 arrows pointing to the 8 in the range, but that doesn't matter. Focus only on the domain. So in other words, let me explain that part real quick. Some of you might say, Mr. Barbie, I knew it wasn't a function. And I say, well, why? Because you have the 4 and the 7 pointing to the 8. That means it's not a function. That's not true, okay? Let me be very clear about that, okay? If you look at this in terms of coordinates, this would be 4, 8 and 7, 8. They both have an 8 in the range, right? But remember we said the range can repeat. It's the domain that can't repeat. So I'm not concerned about 4 and 7 both pointing to 8. I'm not concerned about that. I am concerned, however, about -2 in the domain. I see 2 arrows leaving the -2. That's what makes this diagram not a function. Okay? So I want to make sure you understand that very, very clearly. Ladies and gentlemen, I want to say this one last point. It's important in math to get the answer right for the right reason. Okay? If a student says to me, well, I said it was not a function, doesn't matter that my explanation's wrong. No, it does matter. It does matter. So just because you said this is not a function doesn't mean that you get full credit. You don't. If you told me that it's not a function because you have an arrow pointing to the 8 from 4 to 8 and 7 to 8, that's wrong. Okay? That is completely wrong. So you get the answer right for the right reason. Don't get the answer right for the wrong reason, because the next time you may not be lucky in your guessing of the answer. All right? Remember, in math, we want to know. We don't want to guess. Okay. So answer, it is not a function. And again, the reason why is because you have 2 arrows leaving the same number in the domain going to 2 different values in the range. That's the reason. Okay? All right. Folks, you have 4 classwork practice problems. Okay? So it says, circle yes if the diagram is a function and no if it's not. Explain. The explanation part is important. Okay? It's important. So I know I'm giving you one small line for the explanation. Try your best to, fit it in there. Okay? Maybe write one row of words on top and then another row of words in the bottom. Okay? Try your best. All right? But the explanation is very important. So you're going to answer 1, 2, 3, 4 by yourself. Circle yes or no. If it's a function, you circle yes. If it's not a function, you circle no. And give me an explanation why. Okay? All right? Give me an explanation why. All right. That's for you to do for classwork. Ladies and gentlemen, let's move on to number 4. Relation in the form of a graph using the vertical line test. Now, folks, let's really get into this because I know for a fact, teaching math for a long time, students don't like graphs. Mr. Barbier, I hate graphs. I never understood them when I was in school. Guess what? I feel your pain. I know exactly what you're talking about. All right. And that's why I'm going to break this down like I always do in a way where you will finally understand. Okay. So let's do it. It says, when a relation is displayed in the form of a graph, as shown in figure A at the right, here's figure A. How do we know if it is a function? To find out, we use the vertical line test, which states if there is any place on the graph where a vertical line intersects the graph more than once, the graph is not a function. Folks, it's that simple, okay? But once again, as always, I have steps for you. Don't worry, I have steps. So follow the steps below to use the vertical line test. Step 1, draw vertical lines on the graph, or just visualize vertical lines on the graph. Now, the reason why I have that extra part, just visualize, sometimes you're taking a test and you can't mark the test, right? If you're taking a state exam and you're told by the test examiner, do not write in the test booklet, then you don't have the option to draw lines on the graph. So you would just visualize vertical lines on the graph. Another thing you can do, ladies and gentlemen, is you can take your pen or pencil. For example, let me show you something, right? If I have a pencil, here it is, and I want to make vertical lines without actually drawing them, look at this graph up here, watch. I can just do this. My pencil represents a vertical line, and I just lay it on top of the graph. See? Just like that. So without drawing the vertical line, I can use my pencil to represent a vertical line. Okay? We're going to do some practice with that later on. Okay, let's continue with our steps. So after we draw or visualize vertical lines on the graph, step 2 says, if there is just one intersecting point, again, that's the key, just one intersecting point for each individual vertical line drawn. Okay, that's another very important part. Each individual vertical line drawn, the graph passes the vertical line test. Okay, let me say that again. If there is just one intersecting point for each individual vertical line drawn, the graph passes the vertical line test and therefore is a function. If there is more than one intersecting point, that means that the graph fails the vertical line test and is not a function. Don't worry, I know some of you are very confused. You're like, Mr. Barbier, I hear what you're saying, but I still don't get it. Guess what? That's what we have examples for, okay? Let's look at these examples, okay? Ladies and gentlemen, you never have to worry when I'm your teacher, okay? I'm gonna break it down until you get it, okay? I will always break it down until you get it. Here we go. Determine whether the graphs below represent functions. Let's look at these examples, okay? Here's figure A, the same figure that was up here, okay? Same figure that was up there. Here's figure A, coming back. Notice I have what's called this is a graph on what's called a coordinate plane, all right? A coordinate plane is always marked by a vertical axis called the y-axis and a horizontal axis called the x-axis, all right? Now, one thing I want to say about the axes, that's the plural term for axis. I want to say this first. the axes that this intersects this and therefore gives me the canvas for which I draw my graph. You need to understand that the axes are not part of the graph, okay? It's just the canvas. Let me explain what I mean by that. If I am a painter, I paint on a canvas, right? If I'm a sketch artist, I draw on a canvas, but the canvas is not the drawing, okay? The canvas is not the painting. It's what I put on the canvas that gives me my drawing. So what I'm telling you is this wavy blue thing, this line here, that's my graph, okay? This wavy thing is my graph. The y-axis and the x-axis, that's not the graph. That's just what, that's my canvas, as I like to say. That's my analogy for it. That's my canvas. I draw the graph on this, this x and y axis, this coordinate plane. That's the math term for it. Coordinate plane, also known as a Cartesian plane. Okay, so this is what I'm focused on. This wavy thing here. Do not pay attention to the y-axis or x-axis. As a matter of fact, make believe that they're not even there. Make believe they're invisible. So let's look at the first set of directions. Draw or visualize vertical lines. You see these dotted lines going down here? That's my vertical lines, okay? I can either draw them or I can visualize them. Now, some of you are wondering, well, Mr. Barbier, how many do you make? Guess what? You only really need to make one. You don't need, here I have 4 of them drawn. But I'm only doing that just to teach the topic. But once you get the topic down, you're going to say, wait a minute, this is super easy. You're going to see. So after we draw or visualize our vertical lines, look for points of intersection, meaning where do I see my vertical line intersecting the graph, meaning the wave, the blue wavy line on that makes up my graph. So folks, look at this. Here's my vertical line on the left. As you can see, it hits the wavy graph, which is basically, when I say the graph, I'm talking about that. I'm not talking about, again, we're not talking about, folks, some of you are saying, wait, Mr. Barbier, but it hits right there too. No. What I'm pointing to right now with my pen, that is not a point of intersection. Why? Because that is the x-axis. I just told you, ignore the x-axis. Make believe it's not even there. Okay, all I'm looking at is my vertical line and where it hits the graph, which is that point right there. You see, I even made a big fat red dot for you. Let me zoom in so you can see it even better. I even made a big fat red dot for you so that you can see, oh, my vertical line is intersecting the graph right there. Boom. Let's look at this vertical line. It's intersecting the graph where? Oh, there it is. Boom, right? Intersecting, boom. Remember, that doesn't count. This is not part of the graph. That's part of the graph. Let's look at this vertical line. It's going up past the x-axis. Don't care about that. Oh, here it is. Boom. My vertical line is intersecting the graph at that point. Here's another vertical line. It's going down, up. There it is, intersecting the graph at that point. Now, ladies and gentlemen, even though I see 4 vertical lines here, and 4 intersecting points. But let's be clear. Each of these intersecting points is on one individual line. So I want to be clear, like, don't say, oh, Mr. Barbier, I see 4 intersecting points. No, you don't see 4 intersecting points. You only see 1 intersecting point for 1 vertical line. That's the key, okay? So I'm drawing 1 vertical line, 1 point of intersection. 1 vertical line, 1 point of intersection. 1, again, individual vertical line, 1 point of intersection. Here again, 1 individual vertical line, 1 point of intersection. So folks, look here. If you see 1 individual line with one intersecting point, guess what? It is a function. Okay, it is a function. Let's look at a more detailed explanation here. In figure A, notice that each individual, that's the key word, guys, individual, one line, one intersecting point, one vertical line, one intersecting point. That's what I mean. Each individual vertical line has only one intersecting point. Therefore, this graph passes the vertical line test and therefore is a function. Okay, that's the key. Now, let's look at this little note. Note, the x-axis is not part of the graph, as I said many times. Therefore, ignore the x-axis completely, okay, when doing the vertical line test, okay? All right, let's look at another example. Here's a graph. Now, you might say, Mr. Barbie, wait, that's an oval. Yeah, but it's also a graph, okay? It's also a graph. Any shape on a coordinate plane is a graph. Anything. It could be an open figure, closed figure, doesn't matter. So here we have a graph. Draw or visualize vertical lines. Once again, okay, we have 4 vertical lines drawn. Again, ladies and gentlemen, you don't have to draw 4. You can draw 1, you can draw 2, you can draw, right, any number you want. Look for points of intersection for each individual line, folks, each individual line. Okay, so look here. We have this individual line, but wait a minute, how many points of intersection do you see now? 1, 2. Ah, look at that. Let's look at another individual line. This one. There is an intersecting point, correct? Let me use another color so we can see this a little bit better. There's intersecting point, yes, right there. And wait a minute, like I said, past the x-axis, don't care about that. Oh, here's another intersecting point. Yes? All right, let's look at another vertical line. Okay, here it goes, here it goes. Up. Oh, wait a minute, it's hitting the graph there. That's a point of intersection. And as I keep going, wait, here's another point of intersection. So that's 2 points of intersection on one line. Here's another one. Here's another vertical line. Point of intersection there and point of intersection there, right? So ladies and gentlemen, but as I said, all I need is one. As long as I draw one vertical line and I see 2 or more points of intersection, guess what, ladies and gentlemen? Not a function. That's simple. Folks, one individual line with 2 intersecting points, not a function. Okay? Not a function. Again, one individual line with 2 intersecting points. Mind you, you might say, well, what if it's 3 intersecting points? What if it's 5 intersecting points? As long as it's more than 1, it's not a function. Okay? As long as you see 2 or more intersecting points on one line, that's the key, on one vertical line, it is not a function. Let's look at this explanation over here. In figure B, notice that each individual vertical line has more than one intersecting point. The graph fails the test and is not a function. Okay? Note, even if just one individual vertical line has more than one intersecting point, the graph is not a function. Okay? So what I'm saying is I don't need 4 vertical lines with 2 or more intersecting points. I just need 1. I just need 1. Okay? As long as I can find even one vertical line with two intersecting points, it is not a function. It's that simple, guys. It is that simple, that simple, that simple. All right? Okay, so folks, that is that. Now, you have on the back, class work practice. Once again, Okay, classwork practice. So let's take a look at the classwork practice. It says, does the graph represent a function? Explain your reasoning. Hint, the vertical line test is demonstrated in example 1. You do the rest. So, example 1, here's what I did for you. I drew the dotted line going, right? Notice I'm only drawing 1. I'm not drawing 2, 3, 4. I told you all I need is 1, okay? So if I draw one vertical line or visualize it, and I can see that it's hitting the graph 1, 2, 2 points of intersection. Therefore, you say it for me, someone. Say it for me. Is this graph a function or not a function? Which one am I going to circle? A or B? I'm hearing someone say, Mr. Barbier, I think it's not a function. Okay, why? Why is it not a function? Because the vertical line is hitting the graph in 2 places, not just 1 place. Therefore, and as I can see here, because it's hitting in 2 places, it represents the fact that I have 2 coordinates with the same x value, right? The same first coordinate. Therefore, it's not a function. It fails the vertical line test. The answer is yes, you are correct. And folks, let me say one more thing. I don't need you to write the coordinates down. You may say, Mr. Barbie, how come you did it just for extra explanation? As long as you draw the vertical line and you can show me 2 points of intersection or more, then that means it is not a function. Okay, it is not a function. All right, but if there's only 1 point of intersection, that means it is a function. And remember that it's called the vertical line test because the line has to go up and down, not across. Okay, not left to right, it has to go vertically up and down. Okay, that's why it's called the vertical line test, not the horizontal line test. Be careful. So, as you do number 2, by yourself, same thing. You can just draw that vertical line or, again, visualize it. Take your pen or pencil. Watch me very carefully. And I'm just going to take my pencil and put it on top of the graph. Okay? And then I can see very clearly, oh, wait a minute. I see a point of intersection, don't I? That point of intersection is right there. Right? That's where my vertical line, represented by the pencil, is intersecting the graph right there. Yes? Now, is that 1 point of intersection or is that 2 points of intersection? Okay, that's only 1. Therefore, tell me this graph is what? Function or not a function? Okay, I just heard someone say, Mr. Barbier, I think it is a function because there's only 1 point of intersection right there. The answer is yes, you are right. It is a function. And your explanation will be because it passes the vertical line test, there is only 1 point of intersection. Very good. Very good. Okay, guys. Very good. Ladies and gentlemen, you are going to do problem number 3 by yourself and problem number 4 by yourself as part of your classwork practice. Now, it doesn't stop there, okay? It doesn't stop there. Because now you have to continue with the homework that I showed you from the previous video. For example, you have to continue with part D. Okay, so let's remember, right? Last video, you were told to do Introduction to Functions homework, part A, part B, and part C, right? And now, having watched this video, you're going to do part D, which, look what's happening, identifying functions, right? You're given ordered pairs, okay? Are you given relations in the form of ordered pairs? Ordered pairs, okay? Closed by a set of braces. You're going to look at this ordered pair, circle one, circle function or not a function, and then explain your reasoning on the lines. Why, tell me why these ordered pairs are functions or they're not functions, one or the other. Okay, you can look at video part 1 to refresh your memory. Then we have the next part of our homework, which is right here. Okay, and notice once again, we have identifying functions in a table. All right, I'm giving you 1, 2, 3, 4 tables. You're going to circle one, function or not a function, for this table. Give me the reason why. Same thing for this one, and that one. Function or not a function, circle the answer and give me the reason why on the lines. Part F, identifying functions in a diagram. Okay, I'm giving you 1, 2, 3, 4 diagrams. Look at the diagram, tell me, circle A function, B not a function, write the explanation on the side. Okay, very simple, you got this. And then finally, we have identifying functions in a graph. Okay, ladies and gentlemen, on this side of the page, you have 9 graphs. Okay, and you are to use the vertical line test. Okay, you can either draw the line right on the graph, or you can visualize a vertical line and tell me if it's A function, circle it, or B not a function, circle it, and then give me the explanation on the lines. Remember, if you don't have a printer and you can't print this out, folks, you can use the visual test here, right? You can visualize. I know you can do it. I know you can visualize a vertical line. All I have to do is take look at it, or take a pencil, lay it right on top, and I can see whether this graph has 1 point of intersection or more than 1 point of intersection. Okay, it's very simple. All right, and then you're going to give me your explanation here on the lines for these 9 graphs. Okay, these 3 up top, then these 3, then these 3 on the bottom. So, ladies and gentlemen, you've got this. You can do it. I trust that you can. You're doing great. Keep working hard. Keep pushing yourself. And I will see you in the next video. Take care.